Let's start our first lesson with chapter 1, which dominantly reviews concepts from general chemistry such as drawing Lewis structures, bonding, hybridization, and molecular properties. I strongly suggest you to review your Gen Chem notes on these topics if you feel you forgot them. Before we start talking about general chemistry concepts, let's think about what is organic chemistry and what are we going to discuss in this class. Organic chemistry is the study of carbon containing molecules. In that molecule, we could have carbon hydrogen bonds, carbon oxygen, carbon nitrogen, or carbon phosphorus bonds. So, molecules such as salts, for example, table salt, and water, they are not organic compounds because they don't have any carbons in them. So, what are we going to study about these organic compounds? In this class, we are going to learn about their structure, how their atoms come together, bonded to one another to make that structure, their reactions, and their synthesis, different ways of making these organic molecules. Why do we need to learn about organic compounds? Why do we care about them? So the answer for these questions is pretty easy. It's because of their applications. The range of application of organic compounds is enormous. We can have organic compounds in pharmaceutical sciences. A lot of medications can be synthesized by organic compounds. You can see the structure of amoxicillin here. They can be useful in fuels or in food industry. Sometimes we can make polymer of organic molecules and make useful compounds such as plastics, or they can even be useful in cosmetics. Carmine acid, the structure is shown here, is in charge of red color in cosmetics. Now, what is it so special about carbon here? Carbon basically has the ability to make strong bonds not only to itself but also to other atoms. And that property makes it possible for millions of carbon containing compounds to exist. Our first job in this course is to be able to draw the structure of organic molecules. And a structure is defined as a specific arrangement of atoms. So, why do we care about that specific arrangement? By knowing the structure of different molecules, we can basically predict their properties. So, for example, if we have molecular formula of C2H6O, there are two ways that we can connect the atoms in this molecular formula together. The first one gives us an ether, which is a colorless gas, and the second way gives us ethanol, which is a clear liquid. So as you can see, these two molecules are completely different molecules with different physical properties. So these two, they have the same molecular formula but different bond connectivity. We call these type of molecules constitutional isomers. So constitutional isomers, they have the same molecular formula but different bond connectivity. And constitutional isomers have different physical properties. Before we learn about drawing organic molecules, let's talk about bonds. So what is actually a bond? A bond is basically a glue that holds atoms in the molecules together. So for example, we have two hydrogen atoms here. Each hydrogen has one valence electrons. They will share that electron together to make a single bond between two hydrogen atoms. So basically each bond is composed of two shared electrons. If you look at this energy diagram here, at the very right of this diagram, the hydrogen atoms are completely separated from each other. As we move forward to the left, the hydrogen atoms are coming closer to each other. Now, by doing that, there are three forces that we need to consider and becomes very important. The first force is the repulsive force between the valence electrons. So we know that electrons are negatively charged. So as these two hydrogen atoms are coming closer, there is a repulsive force between two electrons in each hydrogen. Also, there is another repulsive force here, which is the repulsive force between the two nuclei. So nuclei are positively charged. Therefore, as we come closer, the nuclei are getting closer. So there is a repulsive force between them. And the third force, which is very important, is the attraction force between the electrons and the nuclei. So as the hydrogen atoms are getting closer to each other, all of these forces are getting stronger. And at specific point, at the balance point, which is this point right here, electrons start rearranging in a way to minimize the repulsive forces and maximize the attractive forces. So this balance point, we call that bond distance. And at this point, the energy of the system becomes minimal. After this point, if the hydrogen atoms keep coming together, the energy of the system increases because the repulsive forces get very important and the whole molecule becomes very unstable. So this is the balance point, the bond distance that hold the atoms in the molecules together. A review from general chemistry. So we know that atoms are made out of three particles: protons, neutrons, and electrons. Protons are positively charged and neutrons are neutral. They both reside in the nucleus. Electrons, which are negatively charged, they reside in orbitals outside the nucleus. So for example, if we consider an atom such as carbon, carbon has the atomic number of 6, meaning that it has 6 protons and 6 neutrons in its nucleus and 6 electrons in orbitals around the nucleus. In this course, what we care about the most is the number of valence electrons. And valence electrons are the electrons in the outermost shell. So for carbon specifically, in its outermost shell, it has 4 valence electrons. All right. So carbon has 4 electrons in its outermost shell, 4 valence electrons. And why do we care about valence electrons in this course? Because these are the electrons that are involved in bonding to make new molecules. Instead of drawing the atomic model for each atom, there is an easier way to identify the number of valence electrons. For group A elements, the group number equals to the number of valence electrons. For example, nitrogen is in group 5A, so it has 5 valence electrons. Beryllium is in group 2A, so it has 2 valence electrons. So as you can see, it is not needed to draw the atomic model to identify the number of valence electrons. The other important thing is that a scientist, Mr. Lewis, he came up with the idea of how to take the atoms and put them together to make the structure of the single molecule. We are going to review his method and his way of doing that. However, before we start focusing on the molecules, I would like to review how we can draw the Lewis dot structure for a single atom. So as we just talked about, nitrogen is in group 5. So the very first thing is that you find a symbol in the periodic table and you identify the number of valence electrons, 5 valence electrons. Then what you need to do, you need to put electrons in 4 sides of that symbol. 1, 2, 3, 4. I already used or put 4 valence electrons around the nitrogen. Nitrogen has 5 valence electrons. Then I start pairing electrons. 1 more and 5. This is how we draw the Lewis dot structure for a single atom. So to practice, if we want to draw Lewis dot structure for carbon, carbon is in group 4. So it has 4 valence electrons. 1, 2, 3, 4. Oxygen is in group 6. It has 6 valence electrons. Put electrons in 4 sides of the atom and then start pairing them. And for bromine, find bromine in the periodic table, group 7. So it has 7 valence electrons. Bromine. And 7. So this is how you draw the Lewis dot structure for different atoms. Now, what do we learn from that Lewis structure for a single atom? We can basically figure out how many bonds can that atom make. So for example, if you look at carbon, carbon has 4 single electrons. That means carbon is capable of making 4 bonds in the molecules. Oxygen, it has 2 single electrons. So oxygen can generally make 2 bonds in the molecules. Bromine, it has 1 single electrons, so it can make 1 bonds in the molecules. Based on that, we can come up with this table. So if you consider a neutral carbon can generally make 4 bonds in the molecule. We call that tetravalent. Nitrogen generally can make 3 bonds in the molecules. Don't forget that we have this pair of electrons here. It's trivalent. Oxygen can make 2 bonds in the molecules. It's divalent. Halogens and hydrogen can make 1 bond in the molecules. They are monovalent. So halogens are generally the atoms in the group 7, fluorine, chlorine, bromine, and iodine.